Hi friends, today I am giving a lecture on heap sort using Heapify property. In the previous video, we are already solving one example problem on heap sort, but in this video, we are solving another example problem on heap sort, but here we have to use one property called Heapify property. Okay, by using this property, how to perform the heap sort, in this video we have to discuss. Okay, now so construct the maximum heap and perform the operation and perform the sorting operation using Heapify on the following elements: 14, 12, 9, 8, 7, 10, 18. Okay, first we have to construct the complete binary tree by using these elements. So first 14 can be taken as a root node. Next 12 can be taken as its left child, and 9 can be taken as right child of 14. Next 8 can be taken as 12 left child, 7 can be taken as 12 right child, 10 can be taken as left child of 9, and 18 can be taken as right child of 18. So this is similar to binary tree construction. Okay, now this complete binary tree can be represented in the array. Okay, so the elements are stored in an array using level by level. In the first level, only one node is there, that can be written 14. Next level 12 and 9 we have to written. In the next level 8, 7, 10, 18 are there. Okay, while you are writing in the array representation, we have to follow level by level. In each level we have to follow from left to right. Okay, in the last level there are 4 nodes are there, so we have to follow from left to right: 8, 7, 10, 18. In the second level there are 2 elements are there, 12 and 9. In the first level only one element is there, that is 14. Okay, so the above binary tree can be represented in the array representation. Okay, next one. Here the Heapify property starts from the last node, to first node. That means, so right to left we have to follow. But in the previous case, we are starting from first index to last index. But in this video, we are using Heapify property. Here we are starting from the last node in the complete binary tree. So from that last node to first node. So this is the important point while performing the sorting operation using Heapify property. Okay, we are starting from the last node to the first node. That is the first point. Second point, adjustments or swappings can be done in downward direction. But in the previous case, adjustment or swappings can be done upward direction. But here in this case, adjustment can be done in downwards. Okay, next, third point, in a complete binary tree, the leaf nodes are located from n by 2 plus 1, that is floor value, to n. So this is, in the complete binary tree, leaf nodes are started from n by 2 plus 1 to n. Suppose here what is n value? How many number of nodes are there? 1, 2, 3, 4, 5, 6, 7. 7 is there. So here we are considering the floor value. So that is n value 7, 7 by 2 plus 1. 7 by 2 is 3.5. We are taking the floor value, that is 3. 3 plus 1, that is 4. 4 to 7. 4 to 7. Index 4 is 4, index 5, index 5, index 7. 4 to 7 are leaf nodes. Okay. So this is the formula we have to use for finding out leaf nodes in the complete binary tree. In the complete binary tree, the leaf nodes are always starts from n by 2 plus 1. Here n by 2 has the floor value, n by 2 plus 1 to n, where n is the number of nodes in the given tree. Next one. Heapify property is applied from the last element to first element, that is from right to left. This point already discussed. Next one. Heapify property starts at the internal node that has the highest array index. Okay. So here 8, 7, 10, 18 are leaf nodes. Okay. What are the internal nodes? 14, 12, 9. So among the internal nodes, which has the highest array index? Here 14 index is 1, 12 index is 2, 9 index is 3. What is the highest array index? That is 3. Now, Heapify property starts at an internal node that has the highest array index. 14 array index is 1, 12 array index is 2, 9 array index is 3. So now highest array index is 3. So now n by 2 array index is n by 2. N by 2 is nothing but 7 by 2, that has the floor value 3.5, that is 3. So Heapify property starts at this place. Why you are starting at this place? I am telling again. Okay. Next one. The time taken to construct the heap using Heapify is big O of n. This is the main advantage. In the previous case, to construct the maximum heap, what is the time taken? Big O of n log n. Because for constructing the maximum heap, so many swappings or adjustments can be done. So number of swappings or adjustments depends on the height of the complete binary tree. Height of the complete binary tree is log n. Here how many number of elements are there? N number of elements are there. So big O of n log n is there. But here the time taken to construct the heap using Heapify is big O of n. This is the major advantage. Okay. Now, how we are performing the Heapify property? Heapify property starts from the last node. Okay. Here 14, 12, 9, 8, 7, 10, 18. 18 is the last node because it has the array index 7. This is the last array index. Now Heapify starts from the last node. Okay. So here we are always concentrate on downwards for a node. Now first we are starts at this place 18. So 18 has any childs? There are no childs are there. Okay. Every leaf node satisfies the maximum heap property because there are no childrens are there. What is the max heap property? Okay, every parent node is greater than the children's nodes values. Okay, for this node, so there are no childrens are there. Now it satisfies the maximum heap property. Next go to next leaf node, that is 10. 10 has no childs are there, no childrens are there. So that it satisfies the maximum heap property. Next 7. 7 has no childrens, so that it satisfies the maximum heap property. Next 8 is there. So 8 does not have any children, so that it satisfies the maximum heap property. So every leaf node satisfies the maximum heap property because it does not have any childs, so that whatever the node value is there, that is the maximum value. Okay. So after that, next go to this one. Index 7 is there, 6 is there, 5 is there, 4 is there. After that, go to index 3. So here 9. Okay, node value 9. Here 9 has two children. One is left child and another one is right child. Okay. So here the parent node value is always greater than its children's nodes values. Here 9 is greater than 10. It is false. 9 is greater than 18. It is also false. First we have to consider the left. Okay, 9 is greater than 10. It is false. Now we have to perform swappings. Swapping or adjustment. So after swapping can be done, 14 is the root node and 12 is the left child and 9 is the right child of 14. But here 9 can be 9 and 10 are swapped. So here 10 is there. Okay. Next, here there are no changes. 8 and 7. So here 9 is there and here 18 is there. Okay. So now here 9 and 18 has the parent 10. Okay. 10 is greater than 9. Yes, it is true. It satisfies the maximum heap property. 10 is greater than 18. It is false. So that we have to perform swappings between these elements. So after swapping, we are getting 14. Its left child is 12. After performing swapping, 18 goes to up and 10 goes to down. And 18 left child is 9. And 12 left child is 8. And 12 right child is 7. Okay. So up to now we have to perform Heapify property on these three elements 9, 10, 18 only. Because now we are considering the node 9. Node 9 has two children 10 and 18. Okay. Now this satisfies the maximum heap property 9, 10, 18. So 9 is compared with 10. So it is false. Now swappings can be done. So 10 goes to up, 9 goes to down. Okay. Now 10 is compared with 9. So 10 is greater than 9. 10 is compared with 18. So it is false. It does not satisfy the maximum heap property. So that adjustment or swapping can be done. 18 goes to up, 10 goes to 9. 10 goes to 18 right child. Okay. Now it is completed. Okay. It satisfies the Heapify property. So next go to this node. This node is 12. Okay. 12 has two children. So one is 8 and another one is 7. So now 12 is greater than 8. Yes, it is true. 12 is greater than 7. Yes, it is true. So now it satisfies the Heapify property. That is maximum heap property. So 12 is greater than 8. 12 is greater than 7. So now this part satisfies the maximum heap property. And this part is also satisfies the maximum heap property. Now 12 and 18 has the parent 14. So after this node is completed, next we go to this node. Okay. So now 14. So 12 and 18 has the parent 14. So 14 has two children. One is 12 and another one is 18. So 14 is compared with 12. 14 is greater than 12 as it satisfies the maximum heap property. Next 14 is compared with 18. 14 is greater than 18. False. It does not satisfy the maximum heap property. So that swappings can be done between these two nodes. So now we are getting, so 18 goes to up and 12 as left child and 14 as right child, and the next one is here, this is 12 left child is 8, 12 right child is 7, 14 left child is 9 and 14 right child is 10. Okay. So now we have to observe maximum heap property is satisfied or not. So 8 and 7 has the parent 12. 12 is greater than 8 as it is true. 12 is greater than 7 as it is true. At both sides it satisfies the maximum heap property. Next, 14 is compared with 9 as it is true. 14 is compared with 10 as it is true. It satisfies the maximum heap property. Next, 12 and 14 has the parent 18. So 18 has left child 12, 18 has right child 14. 18 is compared with 12, 18 is greater than 12. 18 is compared with 14, 18 is greater than 14. So it satisfies maximum heap property on left subtree and right subtree. So that this is the maximum heap we are getting. Okay. So up to now I am telling the once again the procedure. So here Heapify we have to start from the last node in the binary tree. So this is a complete binary tree. What is the last node? So this is 18. 18 is the last node. Now we have to start the Heapify procedure from that node to the right. Okay, to the right, to the left. So we are start at the right. This is the last node in the complete binary tree. From that onwards, we have to go to left. Okay. So how we are saying that this is the last node? We have to represent this tree in the binary form. So in the binary form, whatever the last node is there, here 18 is the last node. Now we have to start the Heapify procedure from that node onwards. Okay. So now, so 18 has no children. So then if any node does not have any childs, hence it satisfies the maximum heap property. A single node satisfies the maximum heap property because it contains the maximum value. So after it satisfies the maximum heap property, then goes to the next node. Next node is, next index is 6. At 6, 10 is there. It is also a leaf node. It satisfies the maximum heap property. It contains the maximum value. Next, go to the next node, that is index 5. Here 7 is there. 7 is also a leaf node. It does not have any child, so that it has the maximum value. It satisfies the maximum heap property. Next, go to the next index, that is 4. Here at index 4, 8 is there. 8 is also a leaf node. It does not contain any childs, so that it satisfies the maximum heap property because it contains the maximum value. Next, go to index 3. At index 3, 9 is there. So 9 has two childs. One is a 10 and another one is 18. Okay. So now we have to check this part. 9, 10, 18. Okay. So 9 is compared with 10. Okay. So 9 is less than 10. It does not satisfy the maximum heap property. So now we have to perform swappings between these two elements. 10 goes to up, 9 goes to down. Okay. Now, again we have to check after performing swapping between 10 and 9. So this is the tree we are getting. Now again we have to check maximum heap property on these three elements. 10 is compared with 9, 10 is greater than 9. 10 is compared with 18, 10 is less than 18. Here at the right child, it does not satisfy the maximum heap property. So that swapping can be done. After performing swapping, 18 goes to up, 10 goes to down. Okay. After performing swapping, again we have to check the maximum heap property is satisfied or not at index 3. Okay. So 18 is compared with 9 as it is true. 18 is compared with 10 as it is true. So it satisfies the maximum heap property. So at index 3, after satisfying the maximum heap property, then goes to index 2. Okay. At index 2, 12 is there. 12 has two childs. One is left child is 8 and another one is right child is 7. 12 is compared with 8. So it is 12 is greater than 8. It satisfies the maximum heap property. 12 is greater than 7. Yes, it satisfies the maximum heap property. Next, so 12, 8, 7 are satisfying the maximum heap property. So 2 is or 3 is completed, 2 is completed. Next go to 1. Next go to at index 1, 14 is there. Okay. So now 14 has two childs. So one is left child and another one is right child. So check it satisfies the maximum heap property or not. 14 is greater than 12. Yes, it is true. It satisfies the maximum heap property. 14 is greater than 18. It is false. It does not satisfy the maximum heap property. So that we have to perform swapping. So 18 goes to this place, 14 goes to this place. So now after swapping can be done. So 18 is the root node. So now we have to check. 18 is the root node. 18 is greater than 12. 18 is greater than 14. Next, 12 is greater than 8. 12 is greater than 7. Next, 14 is greater than 9. 14 is greater than 10. So this is the maximum heap we are getting. So this is the max heap using Heapify property. Heapify property. Okay, so here the first part is completed. So heap sort contains two phases. Construct the maximum heap. Here the maximum heap is constructed, is completed. Now how to perform the sorting operation. In the case of Heapify, we have to consider a node and its childrens. Okay, so if they are satisfying the maximum heap property, yes, it satisfies the Heapify property also. If it is not satisfies the maximum heap property, now swappings or adjustments can be done until you reach the maximum heap property satisfied.